the AI part. So today I'm starting my discussion with a small terminology that related to the data science plus AI actually. The variables and the feature representation. I'm not going to discuss much more details in feature representation. Then I'm planning to discuss machine learning, uh, model selection and evaluation, classification, basic classification, algorithms, gain and decision trees, SVMs and stuff. Then I'm going to discuss assemble methods, um, random forest for an example. Then finally we'll discuss one of key point in machine learning or training these models, and one of biggest issue that we are facing in this machine learning process, or like discuss this overfitting and underfitting, then how to resolve and how this regularization comes to the context and how it supports us to get the best. So that's the key plan today. As I told you, if there's time permits, I'm definitely going through much more statistical work also, but I'm not sure. Somehow, if there's time is a key part, key constraint in this case, definitely I'll take some of like a bit of time in day three, then I will discuss that also. That's my key plan. So first of all, we'll go through a couple of things that we want to understand. The very first thing that we need to understand under this data science or machine learning, both aspects. Actually, these are two separate parts, but connected with each other. So both of these things supports one to another one. Right? So without data science, we can't go for artificial intelligence. That's the core consideration. Then every time we generated much more data, that means we can have much more stronger data model. So it's like a very competent flow of data to take a decision. To take a decision, whatever things, we need to understand what are the variables that we are playing with. So how we are going to take variables in our context. Basically, in very high level, we have two main types of variables. One is an independent variable. The other one is the dependent variable. So you can see in my screen, I have given these variables in here, and some of common names that in people like what you call industry and academia and different kinds of people, there might be some minor differences, but once we considered like same. For an example, independent variables are discussing exposed variable, control variable, exploratory variable, manipulated variable. Different kinds of namings might be fine, but at the end of the day, the author or the person who is willing to speak this independent variable. In the other hand, you can see the same thing for the dependent variable. We have a lot of names. I have given some of names: outcome variable, control variable, explain variable, and response variable kind of things. So you could see the same kind of a scenario that people are speaking. Or once you are reading an article or reading a book, different kinds of names that we use for the same thing, for the same dependent and independent variable. But in a very high level, we have dependence and independence variables. There might be minor differences, but in general, it's same. We'll understand first of all what is this independent variable and what is this dependent variable. I have a very simple example in here. You can see in my screen. We have dependent variables every time. We get an example. We are doing a research, or we are doing predictive analytics or whatever, an analysis, or we are going to predict how this plant is growing according to some factors, right? Some factors. What kind of factors that we have? We can consider fertilizer, we can consider the amount of water, we can consider the sunlight, right? The hour of exposed to the sunlight, and many other factors we can find. All of these factors are affecting to grow a plant. I believe this is grade 5 4 kind of a science knowledge. Everyone knows this kind of a scenario. So what happens in this case? All of these factors are affecting to the growth of this plant. Right? What we are going to do, we are going to control amount of water. We are going to control amount of water, and we keep other all factors fixed, right? I'll explain a bit more. Now we have three plants in here. We have A, we have B, we have C, right? We have three plants in here. What we are going to do, we are going to expose these three plants 3 hours per day, right? Same place, same sunlight. We are exposed to sunlight. And the fertilizer, same amount. That means fixed. Other all variables or the changing factors are fixed. Right? So once we fixed all of these things, then one remaining that we are doing, like what we are going to check, what we are going to analyze, what we are going to test. In this case, we are changing the amount of water. For an example, this is per day 5 milliliters, and here 10 milliliters. Right? Here we have 2 milliliters per day. We'll get an example. And we have these kinds of changes in here. Changes means we have some different values for the water, not for any other factor. Right? Any other factor, it's fixed. Fertilizer this much, it's fixed. Sunlight fixed, and all of these factors are fixed, but the amount of water is the different or the differentiated of this research or the activity that we are doing. According to the amount of water that we pour to the plant, what we are going to do, we are trying to figure out size of the plant, number of leaves, living or dead. Right? As we already know, according to the amount that we pour to a plant, definitely plants will grow in a different levels, and number of leaves are different. And not only that, we have to check whether it's living or dead too. Right? So that's the whole story. In this scenario, what we are going to do now, we are going to we'll get an example size of plant, right? Here we can find this tree 1, tree 2, and tree 3. So, or else what I'm going to do is, to make my life easy, I'm going to draw 3 graphs. Right? 3 graphs instead of 1. To make my life easy, I have drawn 3 graphs. This is my plant A, this is my plant B, and this is my plant C. And what I'm going to do is, I'm going to check the growth of the plant. So now this plant A is growing day 1, day 2, day 3, day 4, day 5, and so on and so forth. It's growing. So this is the growth of this plant, right? In 1 centimeter, 2 centimeter, 3 centimeter, and so on and so forth. Right? You can understand all of these things. This is centimeters, and these are the days. Right? For the plant B also, it might start it, then after a while, it's dead, not grown at all. C, it's growing, right? It's growing, but it's not, it's growing, it's not expected speed or the very highest speed, right? Very high speed, it's growing, but it's like very slower. At the end of the day, what we are going to find, what is the final finding in this case? This is the optimal level for this plant. Optimal level of water that we need to pour, the optimal amount of water per day that we need to pour for a plant for the best growth. Other findings, if you added this much of water, this plant will grow. And if you added this much of water, this plant will grow, but not the optimal size of the plant. That's the point of the story, that we need to understand the independence and the dependence of these variables. So we have to clearly understand what we are going to control, and what are the fixed or the factors that we are not changing, and what is the factor that we are going to analyze. Throughout machine learning and data science, we can have one independent and a one dependent, one to one. But usual scenario, we have multiple independents and multiple dependents for that. So ultimately, we have to analyze very complicated story, because what we need to do is we need to take thousands of millions of same kind of plant, and we have to try different kinds of approaches. Then only we can come up to the optimal. So, but I have given very high level explanation to understand what is this independent variable and a dependent variable. Next, we'll get another example. In this case, exploratory variable is the academic motivation at the start of the school year. You can see the academic motivation, higher academic motivation. The number of hours will get the number of hours that you are learning. And the GPA. This is something that you can control, right? You can learn 1 hour, 2 hour, 3 hour, 4 hour, whatever the hours that you can keep fixed. So you can decide how many hours that I'm going to learn. But GPA is not something under your control, right? It's all about something that comes to you. It's not under your control. But what we are going to do, we are going to find out whether this number of hours is affecting for GPA or not, right? So according to this case, we can find if a person given much more time effort, then the higher GPA is in there. But this is an example scenario. Don't get whether this is a true or false or something. You just understand what is this exploratory variable and the response variable, right? So that's the point that I want to give to you, right? I believe you got something. I have disabled many things to avoid the stuff, but you can write some questions in a paper. Then you can ask me at the end of the time. I believe the chat is enabled for everyone, so you can chat with me probably. If not, let me know. Then I'll try to enable the chat, right? So you can chat with me. Then you can ask any questions. I have disabled all the microphones and stuff. Like it's much easy for everyone. So if you have any questions, feel free to ask. Then I'll answer your questions in suitable time. Next, we'll go to this consideration, the variables and the features. Many places you can see variables and features are commonly discussed, or same meaning that we are telling. Variable is a feature. Generally, yes, of course, we have to agree. Very general context in many documentations we can find, but there are some modifications, some of changes, or some of distinct points that we can find under these variables and features. A variable is a broader term, according to this. Variable is a broader term that refers to any quantity that can be measured or controlled. It can be include not only features but also other types of data, right? So at a glance you can understand, there's some difference in this case. What is the difference is we have some other types of data too. What are the examples? Labels, targets, variables are in supervised learning. Sometimes you haven't learned what is this supervised learning. Sooner or later you learn what is this supervised learning, and you learn much more things in here. Next, we'll see these features, right? The key term is variable, and we have another term known as features. It's specifically referred to the input variables or the attributes that are used to describe data in machine learning model. So, in some of the things that we are inherited from other practices like statistics, So variables and math, like math kind of things are like definitely interfering for this data science. So definitely we have some different kinds of things in here and there. So that's why these variables and features are come together. But in general, my suggestion is go for the term features than variables as much as, because it specifically characterizes or the properties that we take into predictions or the classifications or any other things. So the whole story of this AI, I'll use this both terms, but don't get upset. And you can see in here and there what kind of things that we have to deal in different places. Let us start machine learning. What is machine learning? If I ask that question, you can use this chat. Quickly give me an answer in your terms. What is machine learning? I'll give 1 minute. Everyone can engage with me, guys. I don't want one-way delivery. Please engage with me. Share your thoughts, whatever things. You can use your chat, right? In your terms, in general terms, you can use chat. All right, thank you. I'm getting answers. Thanks for your input. Uh, yes, uh, general terms. Yes, of course, all these answers are very good. I really appreciate. Very good. What is this machines doing, right? So thank you for your inputs. It's very good actually. So we'll see in a very general context what kind of thing that we have under this machine learning. Machine learning is a subfield of artificial intelligence that empowers computers to learn from data and improve their performance over time, all without explicit programming. Now, the problem that we want to see, we want to understand in here is how to write a program to identify uh, an image, right? An image. That image consists apple and orange. You see, this is an image we have. We have an apple and we have an orange, right? Now, how we are going to understand as a human? At a glance, you can understand, all right, this is an apple, this is an orange. But for a machine, what we need to do? We need to write if condition. I'm pretty sure you all aware with this programming. Right? If condition, if color equals, then we are telling red, then it's an apple. If color equals orange, then we are telling it's orange. If skin type is smooth or rough, then we can tell this is an apple, this is an orange. What we have to do at the end of the day, we have to write thousands of millions of if else conditions, right? Because if we consider this feature and that feature, if both features are same in a same code, like different objects, then we are in a big trouble. So what we need to do now, we need to tell to the program or to the computer, here we have some object in here, it's an apple. You need to understand this is an apple, right? So you all are doing learning, like you all are using this chat GPT and all of these things, probably, I'm pretty sure. So what happens in this case? They have fed thousands of millions of data to them to learn from data, learn from data, and improve their performance over time. At the beginning, very first time, it might be not generate the perfect things, but after a while, once we feed much more data, then our performance is getting enhanced. And most important point is, without explicitly telling this is an apple or this is an orange. So machine learning is quite complicated. In general terms, what we can tell, if we have set of data and if we have an algorithm to understand that data, and if we can give some output using that algorithm without explicitly programming, in such context is basically we can discuss machine learning, or a machine that we can understand everything. Under this context, very near three aspects we need to understand. One is AI, one is ML, the other one is DL. Artificial intelligence is the technique that enables machines to mimic the human behavior. And machine learning is a subset. Right? Machine learning and artificial intelligence are two different aspects. And these machine learning use statistical models and many other models, actually, not just statistical model, many other models plus algorithms to improve the experience. Eventually, like the finally, we have deep learning. It's a subset of machine learning, makes computationally multi-layered neural networks like human brain. This is like a human brain, very complicated architecture we have. And at the end of the day, this architecture would be able to understand all of these inputs, and it would be able to process nicely, and it can differentiate all of these apples and oranges and whatever blah 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 things. I believe you got very high level understanding what is this machine learning and artificial intelligence and deep learning. Actually, please go much more because I'm giving a very summarized discussion. Unless this could be around half an hour of a discussion, but I'm going like very quicker to give the essentials for you. In general definition, or the most powerful person or the someone is telling the field of study that gives computers the ability to learn without being explicitly programmed. Again, emphasized another one. What we are telling, we are telling, we want at the end of the day, without writing programs. I'm pretty sure everyone is happy, right? The people who do worried with this programming, oh my God, the problem is resolved. We don't want to write programs. Instead, it's understanding everything. Yes, of course. But we have to develop algorithms to understand. What are these algorithms? We'll discuss later on. Generally, in very simple terms, face recognition. You have some features in a face, yeah, nose, ears, and all of these things. Then we can tell here, hey, this is a human face. And nowadays, we have much more complicated data, mask detection, helmet detection, same component of the body like the head and the face, but different manipulations we have. For these different manipulations, we are not writing specific if else conditions, we are not writing switch cases, we are not writing different kinds of loops and stuff, but we use some statistical and other machine other aspects to understand what is this object, what is this text, and not only that, many other things, actually many other things. Upon that, what we are going to do is we are telling, hey, this is an apple, this is an orange, or whatever things. So generally, the key point is without being explicitly programmed, right? We have set of data, then we have set of statistical and machine learning algorithms. We have data, here we have data, we have machine learning and statistical algorithms here. The data fed to the algorithms and the statistical models. Upon that, we are creating a model. We have a model. Then this model could be able to predict or classify your whatever things and give something at the end of the day to the out. So initially what we need to do is we need to feed much more data. That's why the data science come to the context. Okay, you can understand. One golden theorem that we are using, garbage in, garbage out. If your data is dirty, if you are using manually curated data, if your data is false or you have used some data randomly, at the end of the day, what you are telling, here I have this data, then machine would learn that data. Using that data, you are teaching incorrect things to another person. Then what happens at the end of the day? Then it telling the same thing back. I'll give a very simple general example for you. I don't know whether you have this experience or not. If you are learning, if you are a Sinhala guy, like especially in universities, first year probably, you want to learn Tamil. And Tamil students needs to learn Sinhala. Right? This is the story, but I'm not pretty sure what happens in this context. In general, national universities, we have this context because we are in hostels, right? So nearby people are Tamils and Sinhalese, so we are discussing in different things. So we want to tell something in Tamil. So we are asking how to tell this in Tamil. For fun, Sinhala people and Tamil people started doing telling some bad words, right? I don't know whether you have this experience or not. Then once that what we are telling, we are feeding bad data or incorrect data to the machine, the human. At the end of the day, once we are going to a shop or somewhere meeting another friend, we are using that word. So the garbage in, garbage out. So that's the point. Same thing for the machines too. We should clearly understand whatever the things that we are using, data should be clean, very pure data we should have. If we have dirty data, all the effort will be really annoying. Right? All right, we have some experienced guy, right? IT, right? Yes, of course, right? So this is the usual scenario, right? We should understand machines are not something like a human. For an example, for a human, yes, of course, we can ask different kinds of people and clarify. But for a machine, not really. Whatever things that we are feeding is some assumed it's correct. So as a data scientist or a machine learning engineer, you are very responsible to feed correct data unless it's a big mess at the end of the day. Right. Keeping that in mind, we'll move a bit of forward. Once we have a large data set, now you should understand we should have a big data set to do whatever things. If we have large data set, we can different kinds of identifications, we can different kinds of classifications, we can go for different kinds of predictions, and so on and so forth. For an example, we can detect a human face, right? We can detect the human face, we can detect the helmet, we can detect the mask, right? Wearing specs or not. All of these things that we can detect nowadays, we don't want thousands of lines. There are already written packages available. We can use it, right? We can use it. So it's not a big deal nowadays. And in the other hand, we have different kinds of classifications, lot of classifications we have. We are classifying whether we have an apple or an orange, whether this plant is well grown or not, whether this is a weed or not. Different kinds of classification tasks we have. Then we have predictions. We are predicting according to the historical things we are trying to tell in future. But keep in mind another golden rule that we are telling for everyone: past is not the future, right? Past is not the future. Please keep in your mind, past is not representing 100% future, but it represents, for the most part, we keep in mind, by using all historical data, we can't predict something 100 out of 100 accurate, because past is not the future. But current or now is the most valuable point to give the prediction. I'll explain a bit more in this same context. I'll give an example. We have thousands of millions of data that are related to the rainfalls in Kalutara district, right? We have humidity, then we have wind data, we have all these data for 100 years, for an example. According to that data, we are predicting for Kalutara, Panadura area, there could be a rain at 4 p.m. today, right? There could be a possibility to rain today 4 p.m. That's the point that we understood, we analyzed, and we have given. But guys, without any data, I mean, with data, we can predict 5, 6, 7, 8, 9, tomorrow, today, midnight, and so on and so forth. But the near future, we can predict easily, or we can have much more confident with current data. For an example, think now we have black clouds throughout the sky and thundering. It gives a big clue for us. Yes, of course, there could be a possibility to have 4 p.m. there's a rain. So past is not future. Don't try to mirror it out. We can't mirror it out as it is, but we can get some clue. Yes, of course. That clue is mostly correct if we have much more features, much more data, and much more confidently we can, if we can confidently elaborate, and we have algorithms and all of these things. I believe we got the story, why and how these things are going here and there. Now, the biggest problem that we are telling is we have to transform this data, right? We have to transform this data to get something. That's the whole story that you are learning throughout this subject of this machine learning. How we are transforming the purified data. Up to purification, it's all about the data scientist job, taking the data, raw data, pre-processing, EDAs, and all of these things. After that, we have very purified data. Then what we are going to do is we are converting into a valuable asset, and that asset could be able to identify different kinds of things, classify different kinds of things, predict different kinds of things. So we have to understand many aspects. For an example, predictive analytics, and we have to think what kind of things that we can do. Like that's why I told the descriptive statistics is missing, so the descriptive work would be like in future, don't worry, but somehow I'll manage that also probably next week. For now, I believe you got some understanding the importance of the data, value of the data, transformation process, and the what kind of things, for an example, statistical inferences, statistical analysis. Then we can use machine learning algorithms to transfer this data, and at the end of the day we have a model. So this model able to predict something or classify something or identify something, right? So that's the overview of this context that we are doing throughout this time. If you have any questions, quickly post it in the chat. All right, we'll go to the general applications. There are a lot of applications you can find that currently that we are using AI, right? Motion AI, Chat GPT, you're one of favorites, right? Chat GPT, oh, Bard, now Bard is not in there, right? So Gemini comes to the context, right? All of these things are based on AI. I just today I got an update from Leonardo AI, one of nice, very nice product, right? That could gives a lot of things. So you can go through all of these things to understand and check, right? Go much more things, see what are the things that we can do, not the traditional way. Always go for new things, because what we have is very limited knowledge. But if we fed thousands of millions of data, then the machines would do the same job better than us. There's no arguments at all, because our brain capacity is very limited, but we can feed thousands, millions, billions, trillions, any amount of data without any problem, right? So these are some of the general examples. You could find many things apart from these things. Now the biggest questions comes to this context is how these machines learn. Already we understood, if we have some statistical works, yes of course, if we have some algorithms, yes of course, we can do something. But even like at the end of the day, we have to understand, yeah, well, how this is actually learned, right? We are teaching, we are teaching for you. Your brain do have all these capacities to understand my words and the visualizations. So your brain neurons, all of these things are processing nicely and storing and giving all of these things at the end of the day. Apart from that, there are nice experiments that we have to understand how you have learned something. I'll get an example. Very small days. We'll get an example. Just you started speaking. Uh, there's a dog walking. Then you're asking, "Amma Tata," right? What is that? Then your mother, your father is telling, it's a dog. What was happened? Your eyes detected that uh, dog's structure, body structure, how it's structured, different kinds of colors, and blah 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 things, all of these things. So our brain is extremely superb. So it understood quickly, okay, it's a dog. After a couple of days, if there's another dog, what you are telling? Ammi, there's a dog. You are teaching to Ammi. How? The story is by example, right? Giving by examples. Thousands of millions of examples we have to feed for a machine. For a human, once you understood, this is a cat, this is a dog, this is a parrot or something. Apart from very niche things, a human brain could understand easily. It's a plant. But if we have a weird thing, it's confused. In such cases, we need these experiences comes to the context. According to the experiences, we can tell many things, right? Not by examples, but by experience. Your learning curve is definitely enhancing if you have much more experiences. Right, we have quick thing in here. We have a nice image in here. You need to tell me whether this is a mop or not. You can use chat option. I'll give 1 minute or less. Quickly tell me. Everyone engage, guys. We have 74 people, so you can engage without any problem, right? Very small class. What is this? This is a mop or not? Or if you can tell something else, yes, of course, I'm open. You can tell this is not a mop, this is something else. This is a um, whatever, right? This is a rug or whatever things. If you feel it's not a mop, if you can tell what is that, I would really appreciate. All right, thank you. Sometimes the traditional learning stops your thinking and engagements, right? So don't worry, you can engage with me, guys. Tell me, I'm not getting good or bad. I'm not getting any decision. Thank you, everyone, for the engagement. Really good, right? So really happy to see your engagements, and it's very nice. So really good. Engage, guys, unless it's sleepy, to be honest, because evening times it's sleepy, right? So engage with me. That's why I'm doing all of these things to like to keep you alive, right? Because as a human is, of course, is the best time to have a small nap. But what to do, right? Come, we have nice image in here, but thanks for everyone's inputs. So we have something in here, guys. We have something in here, and we have a stick in here, and there is something in here. As per your learning, your examples, right? As per the examples that you received up to now, it is most probably a mop, because according to the reasoning and arguing, your brain is telling. Here we have a stick, and there's some notification. The mop is the wet flow something, and we have, and it's kind of a big part in here, right? So it's probably a mop. If you are telling it's a dog, then you are telling by experience, because you saw this image somewhere else. At the very first time, it's very hard to understand whether this is a dog or a mop, right? We'll see what happens in this case. The dog, right? It's a dog. Now, this is the story of machine learning and the human brain and understanding all of these things, because we fed thousands of millions of examples of dogs images to our brain, and our brain was able to understand here we have a dog. But unfortunately, this incident, this experience, we didn't receive up to now. Today we got that experience. Today is the very first day that you got this experience. Oh, some of you got this experience in somewhere, but I will keep assumed that this is the very first day. Now here onwards, without any problem, oh, now you are thinking whether this is a mop or a dog, right? So this is the whole story. But you know the story of these machines. For machines, what we need to do is we are feeding thousands of millions of images of dogs, right? More and more and more different kinds of dogs, different shapes, different angles, different colors, different sizes. So at the end of the day, lot of different features we are feeding to these machines. So what happens, these machines are understanding here, hey, this is kind of this and that and this and that, hence this should be a dog. That's the nicest story that we have to understand, right? Because we have no experience with thousands of millions of things, but machines, once we are training to the machines, if we have thousands of millions of data, we can easily feed and we can tell all of these things easily, right? I believe it's interesting, right? Here we have different kinds of data types in machine learning. Specifically, we have numerical data, then we have categorical data. What we, in my general terms, what I'm telling is always, if we can map into a linear line, then it's a numerical data. If you can't map into a linear line, you can consider it as a categorical data. If it is a bit complicated, I'll give an example. If you want to see values 100 to 200, so it's basically a numerical data, because we have a range in here. If we have red, green, blue, right? Red, green, blue, we can't add values into this kind of a line, right? Those are three separate things. So we, these kinds of separate things, what we are telling is, for my ending, what I'm telling is always, it's easy to understand, it's a categorical data. In programming aspect, you are using if conditions for numerical data for the most part. Categorical data, you are using switch, but I'm speaking in Java context. In different programming languages, we don't have this switch in the here and there, so we have to use if color equals red kind of. So that's the point of these data types in machine learning. We have much more important data to be discussed: numerical data, categorical data, text data, image data, audio, time series, blah 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 blah. Lot of things, different kinds of data we have. Numerical data, again, in very general terms, if a continuous variable we can map into a line, it's basically a numerical data. Categorical data, there might be a nominal or an ordinal data, for an example, color, gender, nationality, and blah 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 things. Text data, it's like the text that you are using, the ISO text or the ASCII text that we are using for natural language processing. Image data, we are detecting from the external captured images, then we are trying to put that data into different kinds of things to analyze, for example, face recognition and blah 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 things. Audio data, it's about taking the voice and the noises to understand whether this is a crow or not, this is an accident or not, this is thunder or not. This kind of audio data classifications we can find in many places. Time series data is another very important factor of the feature of data, or key element of this data science and machine learning, because we have a separate branch for that. So this time series data, we are plotting against to the time. There's a series of data, then according to this data, we are plotting and mapping and get some output. We have seasonalities and many other aspects in there to understand how this data is move. And at the end of the day, we can tell, okay, according to this data, well, this is the output. Shall I give an example? You got SMS, don't cook Thursday, don't cook Tuesday. What is the reason behind that? According to the time series data, these organizations understood the minimal businesses are going Thursdays and Tuesdays, or simply we'll kill Tuesday. Minimal businesses are going on Tuesdays. Then what they are doing? Hey, come, we have a promotion, because they want to keep the business aligned to the success. So that's the point. This is the value of this time series data. Apart from these factors, we have lot of types of detailed data we can find, but generally it's all about how you apply to a specific context. Next, we'll see this machine learning process. Now we understood we have data, we have some processing part, we have some models, and at the end of the day, we are doing something like we are telling something to the society or the output. This is another story that I want to tell you. We have data, right? This is the initial point. We have new data, very new data, or raw data, or the clean data, whatever the data at the end of the day, right? If you are trying to use for machine learning, as I told you from the beginning onwards, we have to take the purified data. That means data is cleaned, right? So we have to go through this cleansing part very well before we are applying to this machine learning algorithm. Once we have this input data, what we are doing is we are applying it to a trained machine learning algorithm. We have lot of algorithms today. We are learning a couple of algorithms like KNN, decision trees, very basics like regressions, like basic things we have. Then, according to these algorithms, what is this algorithm? It's a predefined structure. There's a common input and a processing and output structure is there. We don't want to bother how it was developed. But if you are doing some PhD kind of thing, yes, of course, you need to understand in detail how these things are going here and there. But in day-to-day life, or what we are telling the applied data science, we don't want to bother how all these internal constructs are developed. If you got some understanding, hey, we can use this logistic regression for two class classifications of the binary classification. That's more than enough. And here I'm going to use this one. Yeah, well, for bachelor's levels, I believe it's more than enough. But if you have time and if you are really enthusiastic, I would strongly encourage you to learn in detail apart from the things that I'm discussing in class. Now we have an algorithm. What we are going to do is we are going to tell it a prediction, classification, or whatever the output. Then if we have correct output, yes, of course, we are happy. We are good to go. In case if it is false, then we are not good to go, something gone wrong. So what we need to do, we need to retrain the algorithm using the training data. Then we are applying into the train ML algorithm, and then we are trying to iterate it throughout a couple of phases till we have a good uh, predictive output or good analytical output. For an example, we can classify a good with a good accuracy. I'm always telling accuracy is not the measurement. We have precisions, F1 score, ROCs, and AUCs, and many other things to find out. But in general, we have to understand, all right, accuracy is more than enough to do some main things. This training data can be labeled or not, right? Labeled or not. Labeling means we know specifically what is the feature is. For an example, we have collected data related to an apple. Yes, guys, give me some example features that we can find. We can tell color, weight, right? Skin type, apple's color, green, red, right? And blah, 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 blah things. Weight, grams, 500 grams, 600 grams, 800 grams, 300 grams, and blah, blah, blah things. Skin, smooth, couple of damages, scratches, uh, smooth, kind of things that we can tell. That means we know what we are feeding to the algorithm, what kind of features that we are going to tell. Hey, you have this feature, you have that feature, and all of these things. In such cases, we are telling these are labeled. I'll discuss much more in supervised learning. But in general terms, if you understood that story, it's more than enough for now. What we are doing, we input the data, train the algorithm, trying to predict. If the results are false, then we retrain it again till we are getting a certain level of accuracy and a precision and I score and all of this. Again, This machine learning workflow is a well-defined workflow. What we are doing is in our day-to-day life, we are asking the right question. We should have sufficient data. We should ask right question perfectly. It's a must. Then we have to prepare the data properly. Then we have to select a proper algorithm to our work. We have different kinds of algorithms. Each algorithm do have some specific involvements, specific usage. According to that, we have to use that algorithm. We have to select the most appropriate algorithm. In case if you are unable to understand what is the most appropriate algorithm, then we have to apply a couple of algorithms related to the same problem or the same question. Then we have to pick the most appropriate algorithm for our work. Eventually, what we are doing is we are trying to go to this training module and rearranging all of these things, executing and all of these things at the end of the day to get a proper output. This is the very high level machine learning workflow, but you could find different kinds of changes or minor modifications and some of major modifications in here and there. Different authors are representing the same workflow in different ways. So this is the way that I'm explaining, but it's open for you. You can go through and research and understand what is the most appropriate and what is the most suitable selection for this context. Let's discuss a couple of things. Again, types of machine learning. What are the main types of machine learning algorithms that we have? We have mainly three machine learning algorithms. What are these three machine learning algorithms? One is supervised learning. The other one is unsupervised learning. The other one is reinforcement learning. I believe everyone heard these words at least. If not, no worries at all. I will discuss each of these types detail the next couple of seconds. You should understand there are more different kinds of algorithms we have, right? We have different kinds of algorithms and learning types, but in very high level this classification is more than enough. If you go through different kinds of articles and papers and books, so you could find different kinds of types, yes, of course. And if you use ChatGPT or any other things, it might generate many other things also. Yes, of course, I'm agreed, but those are not the major things, those are minor things. If you are getting a question, what are the major types of machine learning, then your answer should be supervised, unsupervised, and reinforcement learning. Supervised learning. Under the supervised learning, what we are doing is we are training an algorithm. What is this training process? Training means giving an example, right? Not a single example, thousands of millions of examples, right? For an example, to teach to a machine, this is a dog, so we have to show thousands of millions of dogs here. All of these are dogs. You have to understand these are the different kinds of features this dog do have. If it is face detection, is of course same thing. We have to feed thousands of millions of human faces. Then we have to tell this one is wearing fixed what we call these spectacles. This one is wearing a mask and blah 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 things. So lot of things we have. Somehow you should understand under the supervised learning, what we are going to do is we are trying to feed what are the features that we are using to train this algorithm. Simply, we know what are the features that we collected to give a prediction, right? So at the end of the day, same example I'll get. If we have an apple, what we need to do is we need to collect all of these data, skin color, shape, weight, and blah 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 things. If we have this kind of name in our header, we don't have headers, yes, of course. In Excel sheet, I'm telling in an Excel sheet, sometimes you have used this Excels in many times, but in many times, guys, we are not using Excels, we are using CSVs, XMLs, and JSONs for our work. But in general, it's more than enough to understand this kind of header in Excel, right? We know what is the feature that we are trying to use for our work, right, at the end of the day. For an example, we have goal of this model to learn this mapping between inputs and outputs. So we are predicting an apple or an orange. So what we are doing is we are getting colors: red, 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 orange, red, green, green, orange, red, green, green, orange, 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 orange. Then we are telling weight is 500, 500, 600, 500, blah, 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 blah. Then we are telling skin type, blah, blah, blah things. Then we have labels in here, the final output. These are the factors or the variables or the features that we taken out, and this is the feature that we are predicting. Oh, the classification. For example, we have apple, 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 orange, apple, orange, apple, orange, apple, 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 orange. Got it? Right. So that's the whole story of this supervised learning. We have clearly defined input fields or features in this case. Some of examples: linear regression, support vector machine, decision trees, and neural networks. Sometimes neural networks is arguable, yes, of course. I don't have any argument, but if you find somewhere it's not a supervised learning, yeah, I agree with you. Don't get upset at all. But these regressions like linear regression, support vectors, like other like cadence, like decision trees. So those are very basic supervised learning algorithms that we are finding in our day-to-day life. Next, we'll go to unsupervised learning. What happens in this unsupervised learning? Now you should tell, well, if it is supervised is with labels, unsupervised means yes, guys, give me the answer. You can use chat. If supervised means with labels, unsupervised means very good. Thank you. Without labels, right? Very good. If supervised learning is with labels, unsupervised means we don't have labels. In other hands, we are telling we have some data set. You learn from that data set. I don't know what is that data is. Right? It's a bit weird, right? Complicated, yes, of course. For an example, think we have a data set like this: x1, x2, right? x2, x3, x4, x5, and then we have y. And we have values in here: 5, 12, 16, 12, 15, 12, 15, 12, 15, 8, 12, and all of these things. The problem is we don't know what is this feature is. That's very complicated compared to the supervised, right? If it is supervised, at least we have some clue. For us, this is a very complicated story, right? Because we don't know what is this feature, but we know the output is. At the end of the day, we are trying to tell here, this is this classification. But to be honest, guys, machines do not bother what is the feature is. Why? They don't know. They don't know there's a concept called height. There's no concept called color. Those are the concepts for us. For computer, all of these things are just general some data sets, isn't it? We don't have anything, right? We don't have anything. Computer stealing. I don't know what is this red color. I haven't seen red color forever. We don't know this noise. For them, it's just, of course, x1, x2, and all of these. Somehow, if we have supervised learning, then for the data collection, pre-processing, and all of these things are very easy for us, not for the machine. But unsupervised learning, again, it's a bit hard for us. That's why we are today without guide and a guide. Supervised learning, it's guided data. We know specifically the input and output, and specifically we know. Under this unsupervised learning, it's totally unguided. We don't know what is the direction that we should go in here and there. It's a very complicated story at the end of the day. For an example, We have hierarchical clustering. Lot of clusterings are there. K means k and all of these things. PCAs, autoencoders, dimension reductions, and sorry, are the very common algorithms we have. Actually, supervised, unsupervised learning using in many places, lot of places. Don't worry. I think you have some lab sessions. During the lab sessions, you learn, get some hands-on experience how to use these algorithms. Because learning theory is no point from my point of view. You should apply it, and then you should do it, and you should experience it. You should find, oh my God, yes, of course I can do this kind of that kind of things in there, here and there. So probably the labs is the best things. To all of the to experiment all of these things, we'll see how the things are going in future. Somehow that's the story of this supervised and unsupervised learning. Any questions, guys? Quickly tell me. All right, if you don't have any questions, guys, you can use this directly chat with me. You don't want to ask the question generally. If it is going throughout, if you are worried for that, you can send a direct message. You can find my name, then for the to section you find my name, and type it and post it. Then it's coming only to me if you are worried to share your thoughts for everyone, right? Yes, good. Self-organization maps, yes, of course. Many things we have, right? We'll see many things. This is a very vast subject, guys. You should spend sufficient time to find and learn all of these things. I'll come to the last discussion, the reinforcement learning. Now we have reinforcement learning. It's based on the uh, feedback from the environment. Right? We are getting rewards and the penalties based on the behavior. I'll give a very simple example to understand this reinforcement learning. How many of you are having this driving license, and how many of you are driving day to day life? And the last question is, how many of you are getting fines from the best people wearing that green color uh, dress and disturbing us while we are driving? Right? There are a set of people, right? Like some posts, they are standing in the roadside and disturbing to us, right? So they are giving some fines, right? What to do? What we are doing, we are at the beginning, age 16, 17, I do, sorry, 18, 19 around. You do whatever the way, right? Right? Yeah, right. So yes, of course, you drive whatever the way that you want. You override your whatever the things, no worries. But after a couple of fines and couple of disturbances because of these green color ISIS people, now you are not doing those all of these things, isn't it? Right? Oh, it's a disturbance because we have some fines. We have to wait for a time. We have to, right? All of these bad things we are getting, right? So, what is that? We are getting a negative reward, right? If you are trying to go really fast, 100 speed in in the road, they are telling here 2,000 fine. There. Next onwards, you are a bit worried, right? It's a negative reward that you are getting, or the penalty that we are telling. Right? It's a penalty for you. If there are a lot of penalties, then you are learning. I do not cross this line. I do not go faster like this. I do not do all of these things. Some penalty is giving a direction to make your life easy, right? Make your life easy. I don't know how many of you have this experience. Once we are traveling to Kandy from Colombo, there's a big hill and it's a annoying place. Especially the story comes if we have a heavy vehicle is going in that road. We know the penalties are in front. some cases like maximum we are getting something, but somehow the story is like that. And in the other hand, some rewards we are getting. In roadside, we are getting rewards actually. None of policemen are giving any cent for you, right? Apart from the disturbances. They are not giving any rewards. But we'll get the story to your university life. If you are doing very good work, you are rewarded with an A plus. You are happy. You are rewarded with A. You are happy. You are rewarded with a medal. You are happy. So all of these rewards are giving you to direct your success, right? To take your life into a success place. The story is like that. If you have negative things, this is not the path. If you have positive things, yes, this is the path. Same thing that we are implementing in machine learning. That kind of learning is known as reinforcement learning. I believe it's much easy to explain in that simple terms, right? If we have positive things, yes, of course, those are the paths that we need to go. If it is negative things, we should not go in that path because we are getting a penalty in that way. So some of examples we have, most popular is Q learning, very very popular. But most of the time, rather than we are doing this reinforcement, we are directly jump into neural networks and stuff because it's much easier than this reinforcement learning. But you should understand how to see this reinforcement learning works in different places. In generally, this story of these machine learning algorithms, again, I'm telling supervised learning, unsupervised learning, we have reinforcement learning. Supervised learning, we can divide into mainly two types of problems that we can solve using supervised learning. One is regression, the other one is classification. Under the regression, we have simple linear regression, multiple linear regression, polynomials and stuff, but I'm not going to discuss in detail all of these things. Please spend a bit of time to understand all of these regressions and stuff. I according to this the guide that given, starting with classification, but I believe classification is not the best place to start our discussion. I believe regression is the best place to start the discussion. Then if we can move to classification, that makes sense, right? We'll go to this story a bit more and we'll understand the model selection and evaluation. Here we have the model selection based on different kinds of algorithms. Simply, model selection means selecting the most appropriate algorithm, and evaluation is according to the algorithm what is the best output that we can get. That's all in very general terms. We'll get very basic machine learning workflow. We learned this machine learning workflow a bit early. Now, according to this story that I want to tell you, we have these representations, we have evaluations, we have optimizations. What we are going to do in this case, guys, we are representation means choosing a feature representation. What are the feature representation? We have feature matrices and many other things. I'll give a couple of references in your course page, then you can go through, then you can understand much more things in here. And the type of classifier, different kinds of things we have. Then what we are doing is we are evaluating that representation, whether it's a good attempt or a bad attempt. It's not the learning that I just told, right? It's not the reinforcement learning that just I told. This evaluation means, is this model is good or bad, right? How much predictions are correct or not. Simply we are telling accuracy, the precision, F1 score, ROC, right? All of these are evaluation methodologies that we are using. Then what we are going to do is we are using this optimization to get some valuable output. What happens is optimization, we are optimizing our product to the best fit. There are a lot of arguments in the world according to these facts. This is the story. But the optimal product is the product that most of the people are choosing. For our case also, we have lot of algorithms. Then we have to find what is the best suitable algorithm that fit for us for the optimization. We'll go to this story a bit more in detail. Now we have training data sets and we have testing data sets. What is this training data set? initially we have a raw data set, guys. Initially we have a big raw data set. That means we have collected images of apples, oranges, bananas, and lemons, right? Or whatever things. Then what we are doing, so sorry, this is an orange again. We'll tell. We collected 1 million records of images, different kinds of apples, different kinds of oranges, different kinds of bananas. What we are doing is the clean data set. I'm telling the clean data set is partitioned into two. Usually we are doing 70% for training and 30% for testing. 30% for testing. That's the process that we are following. 30, 70. Or else you can use 80% of the raw data for the training purposes. Remaining 20 we can use for testing purposes. That means the original data set is divided. But this testing data is not shown when we are developing the machine learning algorithm or training the machine learning algorithm. Got it? Now what we are going to do? We are trying to understand features, skin color, weight, and all of these features. Then what we are going to do is we are going to apply to machine learning algorithm. We have a couple of algorithms. We are picking the most suitable or the appropriate algorithm. Then what we are doing is we are developing this predictive model. For the predictive model, what we are doing is we have some test data. The original data is divided, right? This data is not shown to this machine learning algorithm development. We don't know. But in this case, what we are doing is we are applying this data and find whether my model can predict correctly or not. Got the story? We have a big set of original data. Then initiate the original data is taken, clean the data. Now we have lot of clean data. This clean data divided into mainly two parts for the training set and the testing set. Training set used to development of the machine learning algorithm based on the features that it received. At this time, this test data is not shown. Now what happens? This data is given once we develop the model and we are trying to check whether this model is predicting correctly or not. That's the high level story of this training and testing data sets. Usually the percentage wise, we have 70 and 30 and 80 and 20. It's just one single line, guys. Don't worry to implement. This is not a big story. It's just one single line to divide this data into two parts. It's just one single line, guaranteed. So you don't want to bother a lot, right? Then for the testing also, you can use the same data. This is the original data set. This is not something that we are taking outside. Then if the predictions are correct, we are telling, all right, accuracy is this much, F1 score is this much, ROC is this much, and all of these things. Any questions, guys, up to now? All right, if you don't have any questions, we'll supervised learning algorithms, linear regression, logistic regression, support vector machine, KNN, knife based, decision trees, arguable, questionable. Don't worry, it might be mapped in here and there. Random forest, decision trees. You can find different kinds of things under this supervised learning. What are the unsupervised learning algorithms? K means hierarchical clustering, PCAs, ICAs, right? And blah 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 things. Here I have taken these two from LinkedIn, guys. I don't know who's the author, the original author. Whoever the author, I have to give the credit. Really appreciated. It's nicely categorized all of these things, different kinds of algorithms, machine learning things, um, with data, without, sorry, with labels, without labels, and state and actions, and different kinds of clustering, classification, associations, dimensional reductions, and blah, 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 blah things. For the algorithm types also, it's nicely given the decision trees, regularization methods, Bayesians, kernel methods, association rules, and blah, 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 blah things. So go through with as much as, guys. My general suggestion is, at the end of the day, I mean, at the end of this course, you should be a person who can do a work, a machine learning work. Simply a person who is ready to join as a data scientist or a machine learning engineer at the end of this course. That's my expectation. You should be able to come to that level. So scope down as much as the algorithms to be tested, because this is for you. Because this is a direct job opened course. I strongly believe this is something that the best thing that you can learn. Give some effort, definitely, right? So you can get a bit more. Yes, for the labs, once it comes to labs, you can learn how to train a model. Right? It's just one single line, guys. Right? I know most of you are really worried. Oh, no, it's training a model. I have to do a lot of things. There's no time, guys. And very limited time to, because you have to complete this 2 hour session. I have only half an hour, half an hour. But to be honest, I'll discuss a bit more. Most of the people are thinking, my God, training a model is really annoying task. It needs very complicated machines. It needs very complicated things. I need all of these big math and stuff. No, right? Don't worry, right? Don't worry. It's not a big deal. It's a myth. The people who just learn theories, they are telling. Right? For example, once I was a research assistant. One girl came and told, "Here I have trained a model in 3 days." Then I just asked, "Seriously, you develop model to train a model in 3 days? Seriously? Tell me the data size, size of the data set. It's 50,000 of data." I told, "Don't lie me. It's just a couple of hours maximum." Right? So it's totally fake. Most of the people like theoretically learn, they don't know practical story. It's different, guys, right? Theoretically telling, oh, it's a big thing, but practically it's very easy. If you know the algorithm, if you know how to apply, then it's not a big deal, guys. Guarantee, right? It's not a big deal. You can, if you learn once, forever, that's it. So don't worry. So don't worry with this training, these things. So another question, how much time, the time taken is always depends on the data and the complexity of the data and the algorithm that you are using. So a lot of facts we have, right? And in the other hand, don't worry with the CPUs, GPUs and other stuff. We can use this cloud resources, then it's free, right? So you can use all of these things. In case if your machines are insufficient, don't worry, you can do it in a cloud, then you can experiment all of these things. They have sufficient GPUs and GPUs and other. So resource size is not a big deal, right? So don't worry, we'll see some of practical stuff. I believe then all of these problems are resolved. Right, again, we have supervised learning under these regressions and the classification. Regression problem means when there's an input and output is focused on a sequence of other continuous values, then regression is the best fit. For an example, if we have the very previous example, water, the days, the same water amount we are pouring to a plant, the days and the growth, we have a we have a nice plotting here. So we can find the data points, then we can draw a line. So it's a regression line in very general. According to X factor, we are telling how the Y factor is going on. In very general, it's more than enough for this regression problem. Under this regression problem, we have a special case known as linear regression. That means the data set that the distribution is like these guys, but we can write draw a specific line in this case, right? Simply we can represent y equals mx plus c, right? Mx plus c kind of a. In such cases, it's a straight line. So all the attributes related to the straight line is applicable in this case. So yes, this is a special case of this regression, which is the linearity. So we have this linear regression at the end of the day. If it is a linear regression, we should be able to represent our equation for that. How we can predict the question, guys? Right. What the question is? The question is how to predict. Now we have population over here, then we have profit in here. What we have done is we have a line in here. A new person comes to the context. Oh, we found someone in the population in here. Then we can tell, hey, according to my analysis, your profit should be like this. That's it, guys. Yes. Don't worry. There's nothing else. Guaranteed. That's all. This is the regression of story. But to be honest, to come to this point, you should spend hours and hours and hours, guys. Right? Within a couple of hours, you can't come to that. But if you have cleaned the data nicely, you have arranged all of this data, then story is not a big deal. It's very easy. Here the story we have this, and we found another one. We found okay, this person is this point in the population of cities. So we draw a line, and according to that, we are telling, hey, we can assume your one is like this. That's the story of this linear regression. Under this linear regression, we have single explanatory variable or a multiple explanatory variable. If it is a single explanatory variable, we are telling it's a simple linear regression. If it or else we are telling it's a multiple linear regression. I'm not going to discuss it much more. Please spend a couple of hours, guys, because I'm unable to cover within this very limited time. Right? Somehow, the next point is the classification. What is this classification? We are classifying different kinds of things. We are trying to tell something in here is like this. For an example, now you can see in this image, we have apples given a lot. These are apples. We specifically told these are apples. Now, what it does, it just taken all of these red color and all of these things, keep recorded here. If I found these features, then it's an apple. The model. Now we have a new data set as the new input data. We classify, we separated into two types, right? Red color, red apples and bananas. If you go to Kaggle, there's a nice experimental learning activity. If you want to do, you can go to Kaggle and go to that Titanic data set. In that Titanic data set, you can find survive or not, a binary classification problem. As a beginner, you can start from there. It's a nice experimental work, guys. Right? When output is required to classify into classes, class A, B, C, died or not, or survived or not, gender is male or female, we are classifying, we are dividing into different parts. So in such cases, we are telling it's a classification problem. Regression problem, we are not classifying. We have a specific linear or a regression in there. But classification, we have different kinds of classes. According to these classes, we are telling blah, 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 blah things. Some of popular classification algorithms, logistic regression, decision trees, support structure machines, KNNs, random forest, naive Bayes. As I told you, right? One algorithm might appear in many places. It might be a regression and a classification. Don't get upset, right? Don't get upset, right? We can find the same thing in different aspects because of its capabilities. Now, logistic regression is a bit confusing story because most of the people believe it's regression. Actually, it's not a regression, it's a binary classification problem. It's the most simplest binary classification. For example, if you want to classify into two classes, the starting point should be the logistic regression, if I'm not mistaken. That makes sense actually, because that's the best of the optimal case that you can do and work in here and there. Then decision trees, again, it's like a tree structure. Then we have some internal representations. Then we are taking the decisions based on those features. I'll discuss it a bit more today. And we have support vector machines. We have hyperplane. According to the hyperplane, we are separating the data into different classes. And the KNNs, we are trying to take the K nearest neighbor. K means a number, and nearest neighbor. What are the nearest for us? Then we have random forest. Then we are telling, all right, we are collecting all of the decision trees and we are coming up to a big forest. That's more than enough to understand, right? We are collecting all of the decision trees and we are coming to one specific forest. That's the random forest, right? Knife based, it's based on the Bayesian theorem. Then we are telling, all right, according to these factors, then these things are there. Next, we'll see a couple of algorithms in here. A logistic algorithm, as I told you, it's the basic and most simplest method to classify data into true or binary classification. This is the class 1, this is a class 2, right? This is a class 1 and this is the class 2. We have two classes in here. According to these two classes, we are classifying the things. If it is under this category, we are telling it is in class 1. If it is in here, it's in here. For an example, pass students, fail students. We have done a big analysis. After the analysis, we are classifying students. We are classifying to binary. Pass students, subject is pass students, subject is fail students. Right? That's the point that we are telling. We are taking up and down, right? Short people and the tall people, black people and white people. All of these are binary classifications. True or false. We are dividing into two classes. Right? In such cases, we are telling logistic regression is the best. Now we'll discuss the decision tree. What is this decision tree? It's just the basic structure that you learn in grade 7 kind of things, right? You have branch 1, you drawn, right? We have like in here, then you have drawn in here, then two parts in here, right? We have another one here, two parts in here. You have drawn, right? Grade 7, 8 probably. Uh, Probably you learn this Rook Satahan. I don't know whether you can remember all of them or not. This is the basic structure, same thing, right? We have original data set, then we are taking into different kind of things. This is the original point of the root that we are telling. This is the root node. This is the topmost of the tree. This is not a tree in this way. The tree is upside down, right? The tree is upside down. If it is a tree, it should be like this, right? All the branches and stuff should be here, right? So this is the root. This is the place that roots are there. Here we have leaves, flowers, and all of these things. But this tree is upside down. That means root is in the top. So the flowers and all of these things are like this root taken to upside down, right? This is the decision tree that we have. We have a root node. Then this root node is right. Then we have different kinds of things to classify, whether it's a sunny day or overcast day or a rain day. According to these things, we are telling. And we are creating different kinds of branches. So the edges are connecting the nodes, right, indicating the outcomes of the decision. Each branch is corresponding to a specific value or a range. And we have internal nodes. All of these things are internal nodes. Internal nodes are the middle nodes in this case. And these are leaf nodes, right? The last nodes that in this case, this is a leaf node and this is a leaf node. My question is, if it is the story of this last node, terminal nodes, at the bottom of the tree, representing the final class label. So it's telling this is the final class, this is the final class, this is the final class, this is the final class. My question is, according to this tree structure, can we consider this overcast as a leaf node or not? Quickly take 10 seconds and give me answer. right? Thank you. I got a couple of answers. So it's a leaf node because it gives the final decision in this case, right? In this case, right? So it's a leaf node. If we have humidity also given in here, then if we have multiple nodes in here, final node, this one is the decision making node. So this is the decision making final node. So this is a leaf node, right? Wherever the end of this node, even end of this tree is, these are the leaf nodes, the last nodes in this case. We have different kinds of things like splitting criteria, pruning, and decision tools. So splitting criteria means how we are going to divide it in each internal nodes, right? We have some criteria like Gini impurity and mean squarers. And for the pruning, we can use remove the branches of the nodes from the tree, right? To avoid overfitting. I'll discuss overfitting. Then the decision rules, the paths that we are taking to take decisions. Right? Then we have another one called random forest. You can see this is one decision tree, another decision tree, and another decision tree. We'll combine all of these decision trees, and at the end of the day, we can tell this is a big set of trees, and we can tell it's a random forest. Right? Somehow it's a big valuation at the end of the day. Then the support vector machine. Support vector machine is basically taking the instances or the data into different paths based on a hyperplane. Now you can see this image, a story of this classification. These are the original uh, nodes that we have, right? Original nodes we have. Now these nodes are divided into two parts, one into the blue part and one into the red part. We have a proper optimal hyperplane, which is the best fit for this case to divide into different kinds of things. And we can see these marginary or the ending corner edges, which are the support vectors for our take or case to get the decision trees. So these are the boundary nodes, right? And the marginary nodes. So this is the story, very high level of this uh, support vector machine. To be honest, guys, it's very summarized discussion. I'm going to give it to you. I know it's not the whole story. There are lot of things to discuss under this SVM. To be honest, it might be like around 2 to 3 hours of discussion for SVM only, right? But I'm giving 2 minutes explanation, which is really summarized the most essentials only. But this is a very advanced algorithm, and the hyperplanes and stuff is going here and there. Sometimes it might be complicated for you, but hang on and see what's going on. Then refer additional materials. Definitely, you could be able to see all of these things easily. Somehow, I would like to take you into a much more easier views now. Here you can see I have taken this discussion into a level that to make your life easy. We have supervised learning, unsupervised learning, and reinforcement learning. The objective is the classification, regression, clustering, association, and we don't know, right? At the end of the day, a lot. We have labels for the classification basically, which a must. Then for the regressions, the best thing is to plot it. Then we can find it. Clustering means dividing into different kinds of groups. Then we have associations or the association tools. Sometimes we have heard association tool mining or combining different kinds of things and providing some of important things. Then we have some feedbacks. You learn this feedback, right? I think you can remember all of these fine stories are reinforcement. Fine. Yes. Then the usage of the things are in here. I can't remember from where I collected. I believe all of these are collected from LinkedIn somewhere, right? Or somewhere that is going on. Then I'm saving Facebook for some communities are sharing. So I'm saving these images for my future users. And here are some of machine learning tools that we can use, statistical and mathematical uses, and general purposes, narrowing solutions, interactive platforms, right? Then Rapper libraries, DS, right? So you go through as much as, guys. If specifically if you are Python guy, you can use this scikit-learn and all of these things, NumPy, SciPy, and many other things. So give a much more effort for this. If you are R guy, there's specific algorithms and stuff to understand. Once it comes to these labs, probably you will experience all of these things. Here again, I'm coming to back to algorithms. I believe it's good for you. Here you can find another algorithm which is k nearest neighbor. What we are doing in this case is we are classifying into different kinds of classes. This is the class 1, this is the class 2, right? This is the class 2. We have two classes here. We have something in here isolated. We don't know what to do for this one. Somehow, if we have a red triangle, then we keep adding to this cluster. If we have what do you call this, green square, then we are adding to this cluster. We are dividing into different classes. Clusters means classes, right? This is class 1 and class 2. Now we expand this class. If we found a whole new object, and under this place, if it is in this place, now the story is different. Now we have to draw a new boundary somewhere and draw a new boundary for these people in somewhere and so on and so forth. That kind of boundary definition or creating these boundaries are the point that doing under k nearest neighbor. It's a lazy learning algorithm, right? It's not explicitly learned model during the training phase. It makes predictions based on the similarity of the new instances to the existing labeled instances in the training dataset. We can find thousands of people we can find thousands of people and in what you call fair skin or white skin and a black skin. And then we can classify them into two classes. If we found another one in a black color, then we can tell genetically this one could be in this cluster, isn't it? We are classifying the people based on the language that we are speaking. A Tamil guy, a Sinhala guy, a French guy, Japanese, German. They classify based on different kinds of features. So this feature similarity or the similar to this one is telling, all right, this is the point of this k. And some of issues, this is very important, guys. Now we have algorithms, we train all of these algorithms, and at the end of the day we might face some of issues while we are developing algorithms and training these algorithms. Very common algorithm issue is the overfitting. Overfitting and underfitting are very basic and very common scenarios. Overfitting means it fit overly for the specific instance. It's specifically for set of people, only for this kind of people. I'll give an example now. I'm telling, I'm going to somewhere very technical place, and I'm giving chocolate for everyone, right? Then, for an example, think a software company, very high tech guys are there in that software company. I'm giving chocolates. Everyone is vanilla. Sorry, we'll change the example. We'll take milk packets, vanilla flavors. We have vanilla and chocolate. We are giving whatever you prefer. You take only one. Then everyone is taking chocolate. Then my conclusion is, if you are a technical guy, you are choosing chocolate milk packets. It's a very bad story because I have taken only a very limited set of people, and sometimes it might be totally incorrect for some set of people. Right? We catered specifically for this kind of an area. We taken out specifically for this kind of people or this kind of a data set. According to that, we are telling here, this is the best solution, the best thing that we can give. But that solution, that architecture or the design, the algorithm is fit for that case only, not for any other case. In such cases, we are telling that is overfitted. You can see we created, we developed new, we have new bed. Bed designed only for specific instance. This person is sleeping in this angle. That's it. Can you sleep or not? It's not fit for you. But once we are developing an algorithm, we should fit for as much as people or as much as instances that available in our case. If it is overfitted, mostly if someone is telling my accuracy is 100 out of 100, that means it's overfitted. So it's a big problem in machine learning and AI. Underfitting means it's too loose. It's too loose. And then we have hyperparameter tuning, which is to parameterize, taking all of these things. Then class imbalance, that is basically we have one class very high, the other one is very low. For an example, we take for our research 100 people. Among the 100 people, 95 are males, 5 females. That is class imbalance. If that is that our work is, or our research work, or our theoretical work, it might be really biased for a specific set of people. That story is the story that comes to this class imbalancing. Then ethical and concerns and bias. This is the whole story. You can see this underfitting and overfitting. This is a good fit. Good fit means there could be like something ups and downs. That's fine. That's okay. We accept it. Then another key point that you need to understand is outliers. How to handle these outliers. Outlier means something that out of, for instance. Now we have taken some set of data, almost all the data in here. And we have one guy in here, totally out. In your mark scheme, everyone is getting 60, 65, 12, about, sorry, 15, 55, 20, 25, 22, 23, and one got 100. It's an outlier. A totally different guy, a totally different story is known as outliers. These outliers are very important. In many cases, I have seen remove the outliers at the beginning, then you do the analysis. My general suggestion is take these outliers separately and analyze. But at a glance, to get much more data, much more like smooth in the data set, we have to remove the outliers. That's the point that we have to understand. As a solution for the other, to solve this overfitting problem, right, we are telling much more generalized data by removing these noises and other things. What we are going to do is we have much more generalized process. The generalization means we are taking it into much more regularization methods. Right? What we are going to do is we are taking this data and we are trying to expand. We can make it simpler and much more generalized version. To convert these generalized versions, we have mainly two types of regularizations. One is the L1 regularization, the other one is the L2 regularization. Both types are important. Both types are applicable in different types of places for the lasso and the regressor. So just go a bit more and find some more additional details in here. I have given two links, guys, very important two links to understand and see and experiment, learn much more harder things. Actually, if you go to YouTube, you can find thousands of videos. This is very common thing nowadays. So you can learn a lot and much more things there. So please don't stop. I have given very high level, I mean extremely high level discussion. It's the most important things only. Please understand, guys, in this 2 hours I have given probably 16 to 25 hours of a discussion, or more than that. Sometimes it might be 30 to 40 hours of in a real lecture could be stringed into here into 2 hours. So it's very I know it's very limited time and very quicker and very speed I have delivered my stuff. I don't know whether how much you got the story or not. Somehow I believe at least you got something in here. I'll quickly take a couple of questions from you. Please ask questions, then I can I can explain a bit more details, much more information for you to understand. In case if you are unable to understand, I'm happy to answer a couple of questions now. There's a question. Share the slide. Yes, of course, I'll share the slides so you can go to your course page and you can tell for the cat one whatever things up to today you'll get, right? For the cat one, things covered under up to today will be a question. Yes, GPU is playing a big role because CPUs are stuck in some level. That's the point. The question is why that GPU is playing a huge role in training data. Yes, of course, because CPUs are limited, right? So GPUs do have all these other core functions, other core values to generate many things or execute many instructions in a very speedier pace. So that's why these GPUs are doing a lot for you. Yeah, there's a question. Do we have to do things in R? Yes, of course, you have to do things in R. Entropy calculations. The question is, any entropy calculations will come for exam? I don't know. For now, I can't tell yes or no, but you'll get much more information in your course page very soon. I don't think so. My answer is I don't think so. Any other questions, guys? Actually, I don't prefer these manual calculations at all. So don't think so. You'll get entropy calculations, but there might be some entropy related stuff in implementation. Well, as a beginner, my first suggestion is learn R since you are learning under R. Uh, but actually, R and Python both are strong. Compared to R, I believe Python is much more competitive in this context. But since our course curriculum is focused on R, so we have to go with R. So first learn R, number one. Then there are a lot of things that to do. We'll see whatever the best things. First of all, the programming skills are very important. Number one. Without that, you can't do anything. The next question is: does R programming will come for exam? Yes, of course. If I'm not mistaken, yes, of course. Somehow I'll give a confirmation for these questions in course page very soon. So up to now, yes, there's a question coming from R. Any other questions, guys? Another question. Um, what what are the maths model need for master in order to start this field? Uh, my suggestion is if you are not much strong in math up to now, don't go for core data science. We have core data science and we have applied data science. Applied data sciences is very easy. You don't want much more math. You just go and play with different kinds of algorithms, implementations, and stuff, right? So it's very simple. You can do a lot easily, to be honest. You don't want to bother with this math at all until you are going for core machine learning, algorithm development, and stuff. Because all of these things are developed, you are using it. But in case if you are planning to come to this core machine learning and data science work, that's a big deal here. You need to understand all these calculus, uh, statistics, algebra in detail. In detail, in the sense, and what we call this permutation and combination in detail. You should understand. So, if you are not a math genius, my suggestion is don't go for that. That makes your life it's very easy, right? So it's very easy. Go for this applied stuff because companies, if you are planning to join to industry, they don't want big math stories because very less uh, stories happening in industry for math related stuff. They implement it. They work, get a work done, right? So that's the point that I want to tell you. Another one is a feedback. What is the feedback? All right. Thank you, Karnal. Right. It's a feedback from one student. Thank you. Um, yes. Another question: how to start this career path as a data scientist or a machine learning engineer? My suggestion is every time for every place, go to LinkedIn and create a job alert. Right. That's the simplest thing, guys. Go to LinkedIn and create a job alert. Whatever in this case for data science. Go and create an alert for data scientist. Then you are getting daily based alerts. What are the requirements in industry? What they want, right? What they want from you. Whether they are expecting big math or just apply something, or Python and R and something, and the theoretical knowledge. Specifically, you should understand very well simple terms. A domain very well. For an example, education domain, travel and transportation, and many other domains might be there. Oil, all of these things are domains. So your domain knowledge is very important. As a data scientist, you can give some valuable things because you know the information related to these features. If you are not a good person or domain knowledge is very low, so you are in a trouble, right? So create some alerts first of all and see what are the frameworks that they want. You learn that, then you are fit for the industry. Apart from the academia, I believe everyone is trying to join to industry, right? If you are planning to become to a researcher or a lecturer, then only you should learn all of these theoretical stuff and stuff, blah 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 things. Much more practicals are important in industry. So your hands should dirty very well. So much more practicals you should do related to that instances that they are asking. For an example, if they are asking a SciPy, or if they are asking scikit-learn, if they are asking any other things. Um, for an example, for process mining, we have an algorithm called AlphaMiner. Some of organizations ask, do you have AlphaMiner knowledge? If you are geospatial data scientist, then they are asking, do you have this and that and this and that and related to the GeoJSONs and stuff? Do you know? These are the specific job requirements. If you created an alert, then you are getting information. Then you analyze whether this is fit for me or not. Then start your career. Align that your CV should be aligned to that job industry or the job market in data scientist. Then apply for that. Definitely, you can get a good job, right? Right. Any other questions? I want to go for machine learning because I like stuff like math and stuff. How can start my career path? Yes, I thought, right? Any other questions? Yes, I want to. Yes, jobs. Yes, right. Right. I spent a couple of minutes from you. I don't know whether it's okay or not. Somehow, if you feel free to contact me in any case, drop an email, tell me your concerns and stuff. I'm really happy to tell you, because I don't know whether how much you got it or not. If it is in traditional class, this content would deliver at least 8 hours, within 8 to 16 hours. Right? So I summarized 2 hours. Very complicated for you sometimes. Somehow, guys, thanks for keeping with me, touch with me. Learn and learn. Right? Do practicals and practicals and practicals. Then theory will automatically comes to your head. Believe me, guaranteed. And that's the whole story that I want to tell you. Thanks for the attendance and thanks for the engagements. Good luck. We'll meet very soon. Have a nice day. Bye bye.